This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. Welcome to section 5.42, everybody. We've got properties of logarithmic functions, more of the same we did yesterday, except today we're going to be reversing the process. Remember what we did yesterday? Well, we're going to do it in the exact opposite direction. We're going to start off with some really long sums of logs, and we're going to combine them all into one big log. Whereas yesterday we took one log and split up a messy expression. Here, when you see subtraction, that means it goes in the denominator. When you see addition, it goes in the numerator. When you see numbers out in front, those are going to be the exponents. So x to the 5th, y in the bottom, z to the 1/4. It all gets combined into one log. One very important thing to remember is that they all have to have the same base. Base b of base b. You can't combine them if they're not the same base. And check this out. Here we've got two expressions, and since they're subtracting them, then subtraction on the outside turns into division on the inside. And this is the numerator, 3x plus 1 here. 3x squared minus 5x minus 2 is here. But you might notice this is something you can factor. You can factor this into 3x plus 1 times x plus 2, and that's exactly what I've written right here. Once I've done that, then you can see that these actually cancel out, and you're just left with 1 in the numerator and x minus 2 in the denominator. So that's that. Here's something else. Log of base a of a to the 8th. Now, you see that this is an exponent. It's on the outside, and then that means it becomes multiplication. Sorry, x8. The exponent of 8 is on the inside, and therefore it becomes multiplication on the outside. You have 8 times log of base a of a. And log of base a of a, let's just figure out what that is. You might remember, but I'll just do it again. In order to, we can convert this into exponential notation from logarithmic notation. Just switch these around, and you get a of x equals a. Well, x has got to equal 1 if this equation is going to be true. So all of this is equal to 1, and 8 times 1 is just 8. Same thing here. You're going to see that we're going to take the exponent, negative t, put it on the front, and take the natural log of e. The natural log of e is just 1. They cancel out. So this is negative t. I wonder if you can do the same thing here. So therefore, we can take the exponent and exponent 3k, put it out in front of times log base 10 of 10. Remember, there's an unwritten 10 right here because it's just a regular log of 10. So I wonder if you can figure out what goes here, what I've blotched out. We can summarize our findings like this. The logarithm of a base to a power. So log of base a of a to the x. These are going to cancel out, just like we saw in the previous two or three examples. These cancel out, and you're just left with x. A base to a logarithmic power, same thing. If you have a log in the exponent of base a, these two ideas are going to cancel out, and you're just left with x. Simplify each of the following. So we've got log of base 4 all in the exponent where the base is 4 here. So the two are going to cancel. We've got k. Here, e to the natural log of 5. Well, these are two inverses, so they cancel, and you're just left with 5. Here, we've got base 10, and here we've got a base 10, log of base 10, so they two cancel, and you get 7t. I'd like you to begin assignment 5D2, copy the problem list, do the first problem, and I'll see you in class. That was short, wasn't it? Yes, it was. Short, just like the element krypton on the periodic table. Take that one, Superman.